Most people think a microwave oven is just a convenient way to quickly reheat leftovers or zap a bag of popcorn. We often take this appliance for granted, not really understanding the science that makes it work. Just blasts food with heat, like some kind of futuristic ray gun, like a super fast oven, shrinking cooking times from hours to minutes. But that's not how it works at all. It's a common misconception that microwaves simply apply intense heat to your food. Instead of adding heat from the outside like a conventional oven or stovetop, which rely on external heat sources, a microwave tricks your food in a way into heating itself, generating warmth from within, from the inside out. This is a crucial distinction that sets it apart from traditional cooking methods. Unlike a stove where the burner heats the pan, which uses conduction to transfer heat from the outside, gradually warming the food from the surface inward in, leading to potential uneven cooking, a microwave uses a device called a magnetron, a clever piece of engineering to create invisible waves, specifically microwaves. These waves don't heat the food directly, they're more like tiny agitators. They make the water molecules inside your food, which are naturally present in most foods, vibrate rapidly, creating friction and consequently heat. Imagine a stadium filled with people, where instead of lighting fires to warm people, a rather inefficient and potentially dangerous method, you play a song that makes everyone dance, getting them moving and active, and generate their own heat through their own energy and movement. That's what microwaves do. They're like the DJ of the food world. They make water molecules in your food dance, jiggling and bumping into each other, creating heat everywhere at once, leading to faster and more even cooking. So, the heat you feel when you take food out of the microwave is actually the aftermath, the result of all that molecular movement, of this molecular dance party, a microscopic rave happening inside your meal. The microwave isn't a heat machine in the traditional sense. It's a physics device that agitates particles, setting off a chain reaction that leads to the warming of your food. The result? Perfectly heated food ready in minutes. Your food heats itself from within evenly and efficiently thanks to the laws of physics, specifically the interaction of electromagnetic waves and water molecules, not a blast of hot air, which is a much less sophisticated approach. Understanding this flips the script, changing our perception on how we think about cooking and the technology we use in our kitchens. The real magic is in the science, the elegant application of physics principles, not the heat itself, but the way the energy is transferred and transformed. And that's just the beginning of the story, a glimpse into the fascinating world of what makes your microwave so fascinating and a testament to the power of physics in our everyday lives. To understand microwaves, we need to talk about the electromagnetic spectrum, the family of energy that includes radio waves, visible light, and X-rays. Microwaves are just a specific type of invisible light nestled between radio and infrared waves. Your microwave oven's magnetron produces waves at about 2.45 GHz, a frequency chosen because it's perfect for interacting with water molecules. Other frequencies would either pass through food or be too dangerous. When you turn on your microwave, you're flooding the chamber with this invisible light, bouncing off the metal walls and targeting water in your food. It's not hot light but energetic light that only certain molecules, mainly water, can absorb. That's why microwaves cook food so efficiently. They're engineered to excite water, not just blast everything with heat. The result is energy turned into heat, right where you want it. Here's the secret. Water molecules are polar, like tiny magnets with a positive and negative side. When microwaves hit your food, their electric fields yank these water molecules back and forth billions of times per second. This rapid movement creates friction, just like rubbing your hands together fast. And that friction generates heat. Billions of water molecules spinning and bumping into each other heat your food from the inside. This process, called dielectric heating, is incredibly efficient. Microwaves penetrate a few centimeters into food, activating water molecules directly, not just on the surface. Fats and some sugars also heat up, but water is the star. That's why foods with more water heat faster and more evenly. The magic is in the wiggling water molecules. So your microwave is really a water molecule agitator, not a traditional heater. That's how it cooks so quickly and thoroughly. Traditional ovens heat food from the outside in using hot air and conduction. Microwaves flip this. They excite water molecules throughout the food, heating it from the inside out. That's why a potato takes an hour in the oven but just minutes in the microwave. However, microwaves can't brown or crisp food. Those delicious crusts and flavors need high dry heat. Microwaves are perfect for reheating leftovers or steaming veggies, but not for baking bread or searing steak. Think of your oven and microwave as different tools for different jobs. Use the microwave for speed and moisture, the oven for browning and texture. Knowing the difference helps you cook smarter. Uh, Ever microwaved lasagna, eagerly anticipating a warm, comforting meal, only to be met with a culinary conundrum? The edges are boiling, practically volcanic, but the center remains stubbornly, disappointingly cold. A culinary iceberg in a sea of scalding cheese? That's because microwaves, unlike the even heat of a conventional oven, bounce around inside the oven cavity in a chaotic dance. This creates a landscape of hot and cold spots, an uneven terrain of thermal energy within your microwave. The turntable, that spinning savior, attempts to mitigate this by moving your food through these zones, offering each section a chance at the microwave's radiant embrace. But alas, for thick foods like lasagna, that cheesy, saucy tower of deliciousness, the heat still struggles to distribute evenly. The microwave's energy can't penetrate deeply enough, quickly enough. Microwaves, those tiny energy waves, only penetrate a few centimeters into the food surface. This means the outer layers, the exposed edges, bear the brunt of the microwave's power, getting hot, sometimes scorching first. The center, however, is a different story. It relies on the much slower process of heat conduction, where the heat from the outer layers gradually makes its way inward. This is the same principle at play in a regular oven, where heat slowly permeates the food from the outside in. So, how do we combat this uneven heating? To help arrange your food in a ring shape on the plate, or even better, leave a space in the middle, creating a hollow center. This allows the microwaves to reach more of the food's surface area, promoting more even heating. And perhaps most importantly, don't skip the standing time after cooking. Resist the urge to dive in immediately. This crucial resting period allows the heat to spread from those scorching hot spots to the stubbornly cold ones, working towards thermal equilibrium. That extra minute or even two can make all the difference in the world. It's the difference between a perfectly heated, satisfying meal and a disappointing encounter with a frozen center, a culinary letdown of epic proportions. The key to microwave mastery is understanding the fundamental principles of how microwaves move and interact with your food. Understanding how your food's shape and density influence heating patterns is also crucial. With a few simple tricks and a little bit of patience, you can outsmart the microwave's inherent unevenness and achieve culinary perfection. Patience in allowing the standing time and thoughtful arrangement of your food are your best friends in the quest for evenly heated microwave meals. Microwave cooking depends almost entirely on water content. Foods high in water like soup or peas heat up fast, sometimes so fast peas pop as steam bursts their skins. Drier foods like bread heat slowly and can turn tough as their small water content evaporates. That's why a jelly donut can be cool outside but scalding inside. The sugary filling heats much faster than the dough. Microwaves heat water, not food itself, so different parts of a meal heat at different rates. Covering food with a damp paper towel helps by adding moisture and evening out the heat. Think like a water detector. More water means faster, hotter results. Understanding this helps you avoid rubbery bread and lava-filled donuts. The golden rule: never put metal in a microwave. Metal reflects microwaves, causing sparks and even fires if there are sharp edges or crinkles. That's why the oven's interior is metal, so to keep waves bouncing inside, not escaping. Safe containers let microwaves pass through glass, ceramic, and many plastics. To test if a container is microwave safe, heat it empty next to a cup of water. If it stays cool, it's safe. Using the right container prevents dangerous arcing and ensures your food cooks evenly. It's not just a suggestion, it's essential for safety. The science is simple: metal and microwaves don't mix. Stick to microwave safe materials for worry-free cooking. Microwaves can't brown or crisp food because they heat water, not surfaces. Browning needs high dry heat, well above the boiling point of water. In a microwave, food rarely gets hotter than 100 degrees or due to 12 degrees, and the environment is steamy, not dry. That's why pizza crust turns soggy and bread gets chewy, not toasty. Some microwaves add grilling elements or use special crisper pans to help, but these are workarounds. The core technology just isn't built for crisping. For golden crusts and seared flavors, stick to your oven or toaster. The microwave is a speedster, not a browning machine. Let's dive into the world of microwaves and bust some common myths that have been circulating for years. We're going to explore the science behind this everyday kitchen appliance and reveal some surprising facts. First up, the idea that microwaves make food radioactive, a complete misconception. Microwaves use non-ionizing radiation, which means they don't have enough energy to alter the atomic structure of food. Instead, they simply make water molecules wiggle and vibrate rapidly, generating heat. This process doesn't mutate your food or make it harmful in any way. In fact, microwaving can often preserve more nutrients in your food compared to other cooking methods like boiling. This is thanks to shorter cooking times, which minimize nutrient breakdown, and the use of less water, which prevents water-soluble vitamins from leaching out. The microwave oven was invented entirely by accident in 1945, a testament to the power of serendipity in scientific discovery. The story goes that Percy Spencer, an engineer at Raytheon, was working with a radar magnetron when he noticed a chocolate bar in his pocket had melted. Intrigued, he began experimenting, and the first commercial microwave, known as the Radar Ange, was born. It was huge, almost 6 feet tall, and weighed over 750 pounds. Quite a contrast to the sleek countertop models we have today. Now, let's move on to a fun and simple experiment you can try at home. Believe it or not, you can actually measure the speed of light using just a microwave and some marshmallows. First, remove the turntable from your microwave. This is crucial for the experiment to work correctly. Next, cover a microwave-safe plate completely with marshmallows, creating a single layer. Place the plate in the microwave and heat it on high for a short burst until you see melted spots appearing on the marshmallows. Carefully remove the plate and measure the distance between the center of two adjacent melted spots. This distance represents half the microwave's wavelength. Now multiply that measured distance by the oven's frequency, which is usually printed on the back of the microwave. The result? You get an approximation of the speed of light, all calculated right in your very own kitchen. So, your microwave is far more than just a convenient way to quickly heat up food. It's a miniature physics lab, a testament to human ingenuity, and a marvel of engineering packed into a compact appliance. So, next time you're using your microwave to reheat leftovers or whip up a quick meal, remember, you're not just heating food, you're harnessing the power of science and a little bit of accidental discovery every single time.